Friends, we are solving NEET model questions on ethers. See the first question. Formation of ether from ethanol is an example of ether from ethanol. Ethanol undergoes dehydration at low temperature 413 kelvins. Sometimes this is given as low temperature. Then it gives ethers. In the presence of concentrated H2SO4, dehydration process takes place. Remove water molecule, then it gives ether C2H5 O C2H5. This is an example of, it is an example of nucleophilic bimolecular reaction. Means it follows, the reaction follows SN2 mechanism, SN2 pathway, because the alcohol is 1 degree alcohol. Ethanol is a 1 degree alcohol. That's the reason it follows SN2 pathway. Suppose if the alcohol is secondary or tertiary, then it follows SN1 pathway. SN1 pathway. Secondary or tertiary alcohols follows SN1 pathway. But here clearly mentioned formation of ether from ethanol. Ethanol is 1 degree alcohol, so it follows SN2 pathway. That's the reason this is considered as bimolecular nucleophilic substitution reaction. The dehydration of secondary and tertiary alcohols, 2 degree alcohols and 3 degree alcohols they are talking about. Secondary alcohol means OH group attached carbon directly attached to two other carbon atoms. Tertiary alcohol, OH group attached carbon is directly attached to three other carbon atoms. Now read the question. The dehydration of secondary and tertiary alcohols to give corresponding ethers is unsuccessful as alkenes are easily formed. It is because of undergoes dehydration. 1 degree alcohol undergoes dehydration, then it gives ethers. But 2 degree, 3 degree alcohols does not gives ethers, it gives alkenes. Because what is the reason? The reason is elimination competes over substitution. Why? Because of this is due to steric hindrance. Number of bulky groups are increases. In case of 2 degree and 3 degree alcohols, number of bulky groups are increases. That's the reason eliminates competes over substitution. The next question is Williamson synthesis. In Williamson synthesis, an alkyl halide is allowed to react with. Williamson synthesis, alkyl halides reacts with sodium alkoxide, then it gives ethers. Sodium alkoxide. Second option is correct option. The next question is Williamson synthesis involves dash mechanism of an alkoxide ion on primary alkyl halide. Williamson synthesis follows SN2 mechanism. That's the reason in Williamson synthesis, the alkyl halide must be 1 degree alkyl halide or methyl halide. 1 degree alkyl halide or methyl halide. See the next question. In Williamson synthesis, if a tertiary alkyl halide is used, the only reaction product formed is, just now we discussed, Williamson synthesis follows SN2 mechanism. That's the reason the alkyl halide must be methyl or 1 degree. Suppose if the alkyl halide is 3 degree, the given alkyl halide is 3 degree alkyl halide. Alkyl halide reacts with the sodium alkoxide, then it gives alkene as a product because elimination competes nucleophilic substitution. This is due to steric hindrance. In 3 degree alkyl halide, number of bulky groups are increases and it gives alkene as a product. C double bond CH2 CH3 plus NABR plus CH3OH. It gives alkene as a product. Next question is, the large difference in boiling point of alcohols and ethers is due to. What is the answer, Amma? The presence of hydrogen bonding in alcohol. You can consider alcohol between hydrogen and oxygen, H bond is possible. But in case of ether, H bond is not possible. Hydrogen bonding is possible between hydrogen fluorine, hydrogen oxygen, hydrogen and nitrogen. Boiling point. Large difference in boiling point. We know that generally boiling point is directly proportional to molecular weight. If molecular weight remains the same, the boiling point is depends upon number of branches. Boiling point is inversely proportional to number of branches. And one more factor is also there, that is hydrogen bonding. What is the relation between boiling point and hydrogen bonding? Boiling point is directly proportional to hydrogen bond. That's the reason fourth option is correct option. See the next question. Both ethoxyethane and butane 1-ol are miscible in water to almost the same extent. It is because oxygen of ether can also form hydrogen bond. See, this is ether. Oxygen of ether forms hydrogen bond with water molecule. We know that solubility is directly proportional to hydrogen bond. Alcohols are easily forms hydrogen bond with water. Not only alcohols, ethers are also forms hydrogen bond with water. So, ethers and butanol are miscible in water to almost same extent. The next question is, in the reaction of alkyl aryl ether with HI, alkyl aryl ether, yes, take alkyl aryl ether C6H5OCH3 reacts with HI. Alkyl aryl ethers reacts with HI follows SN2 pathway and break the bond between alkyl group carbon atom and oxygen atom. Then oxygen gets negative charge, alkyl group carbon gets positive charge. break the bond between hydrogen and iodine. Hydrogen gets positive charge, iodine gets negative charge, and it gives C6H5OH plus CH3I. So what is the correct answer? The answer is alkyl oxygen bond due to the more stable aryl oxygen bond. Yes, alkyl oxygen bond is less stable. Aryl oxygen bond is more stable. And one more reason is it follows a SN2 pathway. The next question is the order of reactivity of hydrogen halides with ethers is as follows. The order of reactivity is Hi is more reactive, after that HBr, finally HCl. So the correct option is fourth option. The next question is anisole undergoes bromination with bromine in ethanoic acid even in the absence of iron 3 bromide. Iron 3 bromide. What is the formula of iron 3? Absence of iron 3 bromide. Iron 3 bromide acts as Lewis acid. That means in the absence of Lewis acid, anisole undergoes bromination. Why? See, in case of anisole, OCH3 group is present. OCH3 group is acts as electron donating group. It is very strong electron donating group, or it is also written as highly active. That's the reason Lewis acid is not required. It only itself generates electrophile. So second option is correct option. See the next question. Anisole reacts with a mixture of concentrated sulfuric acid and a nitric acid. Reaction with H2SO4 and HNO3. That means what is the process? The process name is called as nitration process. In case of nitration, what is the electrophile? NO2 plus is acts as electrophile. First of all, consider anisole. In case of anisole, OCH3 group is acts as electron donating group. Electron donating groups are ring activators and it gives ortho and para product. So substitute NO2 group at ortho position as well as at para position. So what is the correct answer? The correct answer is third option. See the next question. Next question is matching model question. First of all, alpha methoxy propionylaldehyde. Prop means 3 carbons. Alpha position methoxy group is present. So one yes. One yes. Only one option is there. So straight away mark second option. See the next question. The IUPAC name of cinnamaldehyde. Cinnamaldehyde IUPAC name is 3-phenyl prop-2-enol. 3-phenyl prop-2-enol. Eth prop. After second position, double bond. CH CH. This is the structure of cinnamaldehyde. So the correct answer is fourth option. See the next question. Match the following. So here very important point. Here CHO group is attached to cyclic compound. So the IUPAC name is ends with carbaldehyde. 1, 2, 3. It is a cyclohexane ring. At first position and third position, carbaldehyde groups are present. So 1s. 1s, how many options? 1, 2, 3 options. Check the next one. This is cyclic ring. Cyclic compound is benzene. First position, third position, aldehyde groups are present. So benzene 1, 2 dicarbaldehyde. 1s, 2r. So the correct option is first option. See the next question. The next question is related to assertion reason type. Bond angles about carbonyl carbon. Yes, this is carbonyl carbon. Around carbonyl carbon, 3 sigma bonds are present, 1 pi bond is present. Pi bonds are not participate in hybridization process. Only sigma bonds are participate in hybridization process. Total number of sigma bonds 3. So it undergoes sp2 hybridization. The bond angle of sp2 hybridization is 120 degrees. Based on this, assertion is correct. Reason is also correct. Reason is correct explanation for assertion. Third option is correct option. Next question is correct statements regarding structure of carbonyl group. First, P given as the carbonyl carbon atom is sp2 hybridized and forms 3 sigma bonds. Yes, statement P is correct. Statement Q. The carbon-oxygen double bond is polarized due to high electronegativity of oxygen relative to carbon. Yes, carbon-oxygen bond is polarized. Oxygen gets negative charge, carbon gets positive charge. Q statement is also correct. Statement R. The carbonyl carbon is nucleophile. No, carbonyl carbon is electrophile. Positively charged. It acts as electrophile. So statement R is wrong. Carbonyl compounds have substantial dipole moment and more polar than ethers. Yes, this is also correct. Based on this, first option is correct option. The next question is conversion of parafluorotoluene to parafluorobenzaldehyde. This is parafluorobenzaldehyde to parafluorobenzaldehyde. In this, methyl group is converted to aldehyde group. So use CrO2Cl2 followed by hydrolysis. Then it gives aldehyde. Methyl group is converted to aldehyde group. So the second option is correct option. Conversion of benzene to benzaldehyde in the presence of CO and HCl. This is which reaction? Gettram and Koch reaction. The next question is correct reaction regarding Rosenmund reaction. In case of Rosenmund reaction, acyl chlorides are converted to aldehyde. In the presence of H2, PDBSO4. The correct option is first option. See the next question. The reagent used in Stephen reduction. What is Stephen reduction? Cyanides or nitriles are converted to aldehydes. Nitriles are converted to aldehydes when Nitriles are undergoes reduction in the presence of SnCl2 and HCl. Then it gives aldehydes. So the fourth option is correct option. See the last question. Which reagent is used to convert acyl chlorides to ketones through a reaction which is prepared from cadmium chloride and Grignard reagent? Acyl chlorides. This is acyl chloride. Acyl chloride converted to ketone. Which reagent is used? Acyl chlorides reacts with dialkyl cadmium. So the correct option is third option. Thank you.